Okay, so we're going to start out with some simple graphing equations. If the light turns off, it's just because it's motion censored, so I'll just wave and it'll come back on, but hope that's not too distracting. So this is called slope-intercept form. Whenever you see the equation of the form y equals mx plus b, this is a slope-intercept form. And what's nice about these is that they're easy to graph, okay? So down here you'll see an example, or a few examples of some slope-intercept forms. This is the general form, okay? So the coefficient on x, the number in front of the variable, this m term just means the slope, okay? So a lot of you guys have heard rise over run. I'm going to talk about that. It's not, I'm going to kind of use some different terminology just to get some things straight. Some students of mine in the past have made some mistakes, so I just want to kind of clear some things up. And then over here, the b term is called the y-intercept, okay? So they're easy to graph when they're in the y equals mx plus b form, as long as you can see and easily see what your slope is and what your y-intercept is. So let's start with the first example. So right here I've got y equals 1/3 x minus 4. So what I like to start with is the y-intercept. You're not always able to do that because if it's off the grid, you may have to change your scale or you just work with what you've got, okay? So the y-intercept here is -4, okay? So the sign is important as well as the number. So if the sign is positive, then your y-intercept is +4. It would be +4 in that case. But if there's a minus sign, it means that the y-intercept is negative. So what we do is we change my color here. We go from the origin and we go down 4. So 1, 2, 3, 4, right there at -4. So y-intercept is a coordinate, and it's 0, -4, okay? So we've gone left and right none and down 4. And then from there, you take a look at your slope, okay? So your slope, or your m, is 1/3. And what that means is from that y-intercept, we're going to go up 1 and right 3. So a lot of people say rise over run, but you have to be careful with the run because a lot of students get confused, and you may be in this boat. Do I go right or left? And whenever you are graphing, I tend to tell my students to go right, okay? So the top number tells you whether to go up or down. The bottom number tells you to go right or left, okay? In this case, actually I just tell them to go right normally, but you can go left. But since this is positive, it's telling me to go up 1. So positive means up, negative means down, okay? And then it tells me to go right 3, okay? So up 1, right 3. And you can continue that pattern. So that went up 1, right 3, and then I'm going to do that again. Up 1, right 3, up 1, right 3, and the pattern continues. Now you can think of this backwards because this isn't the entire line. Remember in one of the previous videos we said that a negative divided by a negative is a positive. So can't I write 1/3 as -1 over -3? Yes, I can. So in this case, since they're equal, from that same y-intercept, this is telling me to go down 1 and left 3, okay? So negative on top means down, negative on bottom means left. So I can go down 1, left 3, down 1, left 3, down 1, left 3. And then I get that whole picture. So once you have all those points plotted, connect them as best you can. Just know that it's going to be a straight line, and that's what it should look like. So that is the line. I'm also going to show you how to graph this on the graphing calculator, just in case. So this is a graphing calculator, and if you're in Algebra 1, if you're just coming in from middle school, you might not have had this. So I'm going to go to y equals, And right here, I'm just going to graph a function. I'm going to graph that same graph. So I'm going to graph, let's see, alpha, no, second, nope. Yeah, okay. So second y equals, is that what it is? Or alpha y equals? Let's see, alpha y equals. Yeah, so if you press alpha y equals, you can tell the calculator to put a fraction in, okay? So I hope you saw that. So 1/3 x minus 4. And that is the function we're dealing with, okay? So if I go to graph, it's going to show me that same graph. When you're graphing these, your goal is to attend to precision. So what's nice about the calculator is it does it for you. If you go back and you look at our example, exactly the same graph here, okay? So we're going to do another example, and I will show this in the calculator. So right here, our slope is positive, and our y-intercept is also positive. So +1, the y-intercept is going to be up 1. So I'm going to draw this with a different color. I'm going to draw this purple, because purple is my new favorite color. Okay, so that is my y-intercept. So from there, I have to know my slope. So y-intercept is 0, 1. Just going to wave for a second so that doesn't go off. And then my slope is 3/5. So that means I'm going to go up 3, so up and right. So I'm going to go up 3, right 1, 2, 3, 4, 5. And you just continue that pattern. So up 3, right 5. So that's kind of off the page. I know it's going to be kind of right there. So I'm just going to do that. So I've got the right-hand side. So how do I go the other way? Well, 3/5 is positive. So it's equal to -3 divided by -5. So this means down 3 and left 5 from that y-intercept, or from any point really on that line. So down 3, left 5. And then I just continue that pattern. Down 3, left 5. And we're off the page again. And just kind of connect the dots. And there it is. And we are done. So, oh yeah, I said I was going to show you that in the calculator. So I'm going to go to y equals. I'm going to clear this out. I'm going to do alpha y equals, just to tell the calculator, alpha y, make sure, alpha y equals, tell it to put a fraction there, so that's going to be 3/5 x plus 1. Press graph, and there's that same graph. Now it may look just slightly different because the scaling on the bottom, this x-axis here, let me make sure you can see my pointer. This x-axis here is kind of bigger than this. The scaling between is bigger than this y-axis. So if I had them closer together, you'd be able to see that. And I might actually just do that because I think it's -10 to 10, but if I change the window, you don't have to do this. I will show you how to do this eventually, but so if you can catch on, you're more than welcome to. And so that's a little closer together, but it's not quite what I want. Let me clean that up, maybe 15. Nope. Oh, I'm doing the y's. I'm dumb. My bad. I need y's to be negative 10 to 10. And the x's to be negative 13. So all this does is it changes the scaling, and you can do more than just this. And I did something wrong. Let's go back, quit. Window. Yeah, forgot to make that negative. Okay, that's going to be a little more accurate, right? Those are closer together, so if you look, it's going to look a lot more accurate than what it did before. So that looks a lot like our line there. Okay, so we got y equals 2x minus 3. So I've got a y-intercept here. My y-intercept, remember that negative comes along with it. So this is 0, negative 3. That's the coordinate. And start with that. And keep this color because I like it. And then my slope is going to be the coefficient on x. But you want to convert it to a fraction. Whenever you're working with graphs of linear equations, the coefficient on x, fractions are going to be your friend. So if you've got a whole number, what you want to do is convert it to a fraction. So my slope is 2. So 2 as a fraction is going to be 2 over 1. Okay? And it's positive. So that means we're going to rise 2 and then go right 1 each time for each one of our plots. So we're going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Okay, so that's the right-hand side. So now we want to go the opposite direction. So 2 over 1, that's a positive slope. So that's equal to negative 2 divided by negative 1. So from that same y-intercept, I'm going to go down 2 and left 1. So down 2, left 1, down 2, left 1, and just connect the dots. And that's the fun part, making pretty pictures with math. I'm sure you love this. I can feel your excitement from home. Okay, y-intercept is 0, negative 1. So we just go ahead and do that. So I put that point there, and then this time my slope is negative 1/2. Okay, so negative modifies the numerator or the denominator. So first we're going to modify the numerator. Okay, so I can write negative 1/2 like this. So that means from that y-intercept, we're going to go down 1 and right 2. Okay? Down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. Okay? Or I can put the negative in the denominator and leave the numerator positive. So I can write it like this for the other side. So in this case, this means go up 1 and left 2 from that y-intercept. So I'm going to go up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. So what you see is that slope is consistent, and I get this straight line. If I can not screw up, that'd be great. There we go. Okay. I'm sorry, it's a little off kilter. Okay. All right. We got another one here. So I encourage you to try this one on your own. Pause the video. So assuming you've had a go at it, y-intercept is 0, 2. And that comes from this b term, okay? Positive 2. And the slope is negative 4 over 3. So we've got another negative slope. So remember, there's two ways to write this. There's negative 4 over 3, which means go down 4 and right 3. Okay, so we're going to do that first. So 1, 2, 3, 4, 1, 2, 3. And I just continue that pattern. So there's that side of the graph. And then we have to write it the other way to get the rest of the graph. So that's going to be positive 4 over negative 3. So that means go up 4 and left 3. So 1, 2, 3, 4, 1, 2, 3. And there we go. And we've got one more. So I want you to try this one out on your own, but there is a little bit of a trick to it. So it's kind of to trip you up. So hopefully you've kind of seen the trick, or at least have thought about it. There's no shame in looking at a solution if you are confused on something. So in our original form, let me go back up to it. Slope-intercept form is y equals mx plus b. Okay, so the constant goes at the back. That's this b term here. Okay, the constant needs to go to the back, but the linear term, right, the variable term, the x and the coefficient, the slope, needs to be the first value if it's written in standard form. Well, not standard form, but if it's written in proper slope-intercept form. So what you'll notice here is you can do the graph from here, but a lot of people may not see, okay, they'll think that this is the slope and this is the y-intercept. But whatever coefficient is on x, that's your slope, okay? So if I write this in slope-intercept form, this is actually going to be negative 4x plus 3. So I hope you caught on to that. So they kind of rearranged the equation there. So my y-intercept is 0, 3. And my slope is negative 4 over 1. So there's two ways to write this slope. So negative 4 over 1 means go down 4 and right 1. Or I can write it as 4 over negative 1, which means go up 4 and down 1. So we're going to start with the top slope. So these are both equal. I want to reiterate this. I don't want to confuse you. But this is just to get the entire graph. So first we're going to plot our y-intercept, which is 0, 3. And then from there, we're going to use this slope to get the right-hand side of the graph. So this is telling us to go down 4 and right 1 continuously. So 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1, and just continues on like that. So I kind of did that one off the page. 1, 2, 3, 4, right 1. So then to get the rest of this graph, I'm going to go up 4 and, not down, left 1. So up 4, left 1. And all that does is it gets us the entire graph. Lets us see and visualize the points on that graph. Okay? And then we've got two more for you here. Y equals 4. And you might be looking at this and you might be saying, okay, I know what the y-intercept is, right? That's a constant term. It has no x with it. I know that it goes through 0, 4, but where's the slope? Well, the slope is actually there. It's hidden, okay? So if I think about this in y equals mx plus b form, I know that b is 4, okay? So y equals mx plus 4 equals 4. So the only way that this term, right, this mx plus b, this this value can be there, but we can't see it, is if m is 0. Okay? And you can plug this in. So let's see what this would be. So y equals 0 times x plus 4. Well, what's 0 times x? Well, it's going to be 0. So I'm left with y equals 4. So what that means is, doesn't matter what the denominator is of the fraction. So 0 over some denominator or some number. That means we rise none, okay? And we go left and right continuously, okay? So whenever you get y equals a number, it's just a straight vertical line, okay? It just stays at 4. So this is what it looks like, right? It's telling us to rise none, okay, and go left. Okay, so let's do that. So I'm not rising. I'm not going down or up. I'm just staying straight, okay? And then the other side, just like that. So it's just a straight line. So whenever you're working with y equals a number, that just means the slope is 0, okay? And that's it. Okay. So then we've got x equals 3. And all that means is it's very similar to y equals a number, but instead of a horizontal line, it's going to be a vertical line, okay? So I like to think of this as infinite rise and no run, okay? That's how I like to think of it. As later on we'll get into something called functions, and this is one of the first examples that you'll see where we call it to be not a function, okay? Vertical lines are a no-no for functions. So x equals 3. And that's what it looks like. And your calculator, I don't think, can graph that. Pretty sure it can't. So I'm going to go through some of these and let you graph them. Show you how to graph them. I'll only do a couple. I think I'll do these two. Negative 4/3 x plus 2. So negative 4 divided by, let me make sure I do that. So alpha y equals, just good practice to get you used to fractions in the calculator. Negative 4/3. It says error syntax. X plus, what was it? 2. There it is. Let's see what the graph looks like. Okay, there it is. So down 4, right 3. And let's just take a look at mine. Very similar. Okay. Let's go back to y equals, clear that out, do the next one. The next one is negative 4x plus 3. I'm going to write it in standard form. Well, not standard form, but proper slope-intercept form. Negative 4x plus 3. So negative 4x plus 3. Kind of a steep slope. Goes right through the y-intercept of 3, so you can compare them. They look the same. So I'm just showing you how to graph these in the calculator. And then you can't do x equals 3, but I'll do y equals 4 just to show you that the calculator even says that it's a straight line, or shows that it's a straight line. So y equals 4. And it just goes straight across. Just like that. So I hope this video was helpful. And it looks like you've got quite a bit to do. but I'll leave you with this. Write the equation of the line. We'll do maybe a couple of these. So the first thing you want to do is you want to figure out, right, y equals mx plus b is your equation of a line, okay? It's slope-intercept form of a line. It's an equation of a line. So that's how you start. That's how I like to start. You don't have to start it this way. But y equals mx plus b, what you want to do is find your b term. That's your y-intercept. So b is the y-intercept. It's where it hits the y-axis. So right here, if I look on this y-axis, I'm looking for where the line crosses it. And it crosses at 5. So that means b is equal to 5. So I've got y equals mx plus, and I'll just write this in a different color for you, 5. Okay? So then I'm going to write the slope in green. So from that y-intercept, I'm going to see when I read from left to right if I'm going downhill or uphill. Okay? So this line, if I read from left to right, it's going downhill. Looks like a downhill slope. So that means my slope is going to be negative. Okay? I'm not rising, I'm going down. Okay? So I went down 1, 2, 3, and right 1. So I'm looking for that next grid, right? The next part of the line that's on the grid is right here. So I went down 1, 2, 3, and right 1. So that means m is equal to negative 3, right? We went down, and right 1. So the slope of this line, right? The equation of this line, let me make sure I write this correct. Y equals negative 3 over 1, that's slope, x plus a y-intercept of 5. Okay? Let's do one more. So this is a positive slope. So y equals mx plus b. I'm going to see what my b term is. So I'm going to look at this y-axis. All right, my y-axis hits at negative 1. So b is equal to negative 1. So I can rewrite this equation. Y equals mx minus 1. And then from that negative 1, I'm going to look for the next point. So the next point that this line crosses through, next defined point, really obvious point, is right here. Okay? So from negative 1, I went up 1, 2, 3. And that's positive, so that's a positive slope. And then I went right 1, 2, 3, 4. It's me. Kind of. I broke it. There we go. That's 4. So that means y equals 3/4 x minus 1. And that's our equation. And then this one, it's a straight vertical line, up and down, okay? So it's not a function. It doesn't go left and right. So that means it's x equals a number. So I have to see where that value is going through, and that value hits the x-axis at 3, so x equals 3. That's the equation of that line, but again, it's not a function, so that is going to come up later. So then here's the fun little practice. So I want you to pause the video. I want you to try this out on your own, and then we're going to graph it. Okay. So it says Bob has 3 cakes. He bakes 5 cakes every 2 hours. So we want to come up with an equation for Bob. So we want to know the amount of, right, cakes he bakes. So I'm going to let y be the total amount of cakes. We know he starts out with 3. So if he starts out with 3 initially, that means that's our y-intercept. Okay? And it says he bakes 5 cakes every 2 hours. So that's going to be 5 cakes times x over 2. And the division by 2, all that means is every 2 hours, I've got 5 more cakes. Okay? So that was kind of my thought process. I can kind of walk you through more of this if you want to talk outside of these videos or outside of class. But when it gives you a stipulation like every 2 hours, if it said every 3 hours, I would have divided by 3. If it said every 4 hours, I would have divided by 4. That just allows you to get that multiple of the numerator every whatever. Okay? So we've got some values to plug into this line. And what we can do is, it wants us to fill out this table, but we don't even have to, really. To graph the function. We know how to do that now, so I'm going to go ahead and graph the function, and then we're going to kind of work backwards and see what we can fill out with this table. So our y-intercept is 3. So we're going to start out at 3. And one thing that I'm going to say about this video, I guess it's just a disagreement. Would I think of negative time? Would I say, okay, I want to see how many cakes he had 6 hours ago? I don't think that's practical. And the reason is because if he starts out with 3 cakes and he bakes 5 every 2 hours, then if I think about 6 hours ago, he's going to have negative cakes baked. Okay? So you don't, whenever you're considering time, you think it to be 0 or positive. Okay? So I'm actually going to kind of mark that out and not talk about it. So the reason why we're graphing these up here is because they're not in context, okay? So you might be wondering, okay, but you went negative on this one. Well, yeah, there's no context. It's just to practice that skill. Whenever you're down here, whenever you're talking about a practical application, you're only going to be thinking about practicality, okay? So you're not going to have negative cakes and you're not going to have negative time unless you have a time machine. And then you can, I guess, have a negative cakes. But if I plug in 0 into this equation, I want to know what the y value is. So x, y. When x equals 0, I've got y equals 5 over 2 times 0 plus 3. Well, 5 over 2 times 0 is going to be 0. Plus 3 is 3, so y is 3. Let me write that out. 5 over 2 times 0 is 0, plus 3 equals 3. And then right here, I've got x equals 4. So I've got y equals 5 times 4 divided by 2 plus 3. So I'm going to kind of clean this up. So I know that 4 divided by 2 is 2. So I'm going to get rid of that fraction as soon as I can. So 4 divided by 2 is 2. So that means that 5 times 4 over 2 is equal to 5 times 2 plus 3. So 5 times 2 is 10 plus 3, which is 13. So I've got 4, 13. And then we said we'd mark this one out. You can do that on your own if you want to. Just know that what I said, time, we don't consider it to be negative whenever we're working with graphs like these. And then I want to know what x is when I have 23 is y. So I have 23 cakes. So if I write that out, I've got y equals 5 over 2x plus 3. And instead of y there, I'm going to have 23 in its place. So I've got 5 over 2x plus 3 equals 23. So what I want to do is I want to get rid of this plus 3 first. So I'm going to subtract 3, and I get 5 over 2x is equal to 20. So the next thing I want to do is I want to notice that 5 is being divided by 2. So what is the opposite of division? Well, the opposite of division is multiplication. So I'm going to multiply both sides by 2. Kind of break this up. So if I multiply both sides by 2, I get 2 divided by 2 is 1, and I'm left with 5x. And on the other side of the equation, I've got, let me make sure that's written so you can see that. I've got 20 times 2. Okay, there's that. I've got 20 times 2 is 40, so I've got 5x equals 40. So I can divide both sides by 5, and I get x is equal to, let's see, 40 divided by 5, it's 8. So x equals 8 when y equals 23. And that's it. So I want to see what this graph looks like. So what I want to do is, from that y-intercept, I want to go up 5. My slope is 5 over 2. I want to go up 5 and right 2. So 1, 2, 3, 4, 5, right 2. And then I can also think of that slope as negative 5 over negative 2, which means I go down 5 and right 2. So from that point, from that y-intercept, I can go down 5, so not right, left, down 5, and left 2. Okay? So I go 1, 2, 3, 4, 5, and left 2. And there it is. Let's look at that. Look at that line on the graphing calculator. We'll call it a day. I want to do this properly. So alpha y equals and there it is. Oh, I meant to put positive. My bad. That was my mistake. My bad. There we go. Now it's right. I just went over and deleted that negative. And there we go. So if I go back, yeah, they're pretty similar. And that's all I got. So I hope that helps.